Hi guys. So in this video, we are going to do the homework questions 1, 3, 7, and 13. Okay. And so these relate to balancing the equations and classification of the balanced reactions. So first of all, balancing the question number 1 here, I'm just using a few of the, the subparts, but you are welcome to use other subparts and, do as many as you do, the more practice you do, the better it is for you. Anyway, so let's look at this. So first, let us look at how many irons. So one iron atom, let's just keep it as atom first of all. So one iron atom, there are 2 atoms of oxygen, there are 2 atoms of iron, and there are 3 atoms of oxygen. Okay, so in this case, we see that the iron and iron, according to the law of conservation of matter, they should be the same. The weight of the reactants and the weight of the product should be the same. The number of the atoms on one side of the reaction should be same as the other side of the reaction. So here we clearly see there is a discrepancy. Iron is not matching and oxygen is also not matching. So what are we going to do? We are going to look at, first of all, look at oxygen. Oxygen is 2 and 3. So obviously you can make 1:2. You can make iron 2, but you cannot make, 3 oxygens on one side and 2 on the other. So in other words, you have to look for a common multiple, and the common multiple here is 6. So common multiple is 6. Okay, so that means 2 times 3 is equal to 6 and 3 times 2 is equal to 6. So we need to make 6 oxygens on both the sides. So if you put 3 here in front, that would mean that 2 times 3 is equal to 6 oxygens. Okay, now you can put 2 here, and that would mean 2 times that 2 is going to apply to iron, and that 2 applies to oxygen. So this is how you will get 4 irons, and now you have 6 oxygens. Okay, so remember that this 3 is a coefficient. This coefficient applies to every single atom. So here 2 applies to iron and 2 applies to oxygen. But remember that every 2 or 3, the 3 only applies to oxygen, 2 only applies to iron. Okay, now, so we got the irons now not balanced. Iron is 4 on one side and 1 on the other side. So if you put 4, that means 1 times 4 is equal to 4. So 4 irons on the other side. Okay, so here we see that there are 4 irons, and we see there are 6 oxygens. So all of this is balanced. Let's look at the next one. The next one is copper oxide with oxygen, giving you copper oxide. So the first one is copper 1 oxide, the other one is copper 2 oxide. So here what's happening? We see that here we have, let me put this in black. We see that here we have 2 coppers and we have 2 oxygens, and here we have 1 oxygen. So a total of 3 oxygens. But on this side, we have 1 copper and you have 1 oxygen. Okay, so we need to change this. 2, if we bring 2 here, so that is going to change the, let's see, 1 second. So now you see here we have copper, which is 1 on one side and 2 on the other side. And oxygens are a total of 3. So there's 1 oxygen plus a 3 oxygen. So 3 oxygens on one side. Now, what can we do? So if we put 2 here, then it doesn't make sense. If we put 4 here, if we put 4, so 4 coppers and 4 oxygens. 1 second. Okay, so we have 4 coppers, 4 oxygens, because this 4 applies to copper and this 4 applies to this oxygen. Now, on this side, we're going to make 4 copper. So how do you do that? You put 2 here. So this 2 times the 2 coppers and 2 times 1 oxygen. So that makes 4 coppers, and that gives you 2 oxygens. And then you have 2 oxygens here. So when you add the 2 together, this gives you 4 oxygens. So 4 oxygens on one side and the 4 oxygens on the other side. Okay, let me just change this, make it look like this is when you add the 2. So 2 oxygens from one and 2 oxygens from the other, make it 4 oxygens. And then you have the four coppers on this side and 4 coppers here. Okay, so that's how this one gets balanced. Now let's look at the third one. Now here, aluminum with copper sulfate gives you copper and aluminum 2 sulfate. So let's see what is given to us already. So we are given one aluminum, and we have 1 copper. Now, look at the sulfate. Sulfate is same on both the sides. So you don't have to break it up into sulfur and oxygens and so forth. So keep it as 1. And there is one sulfate. Okay, this side. And it's okay not to put charges. So it is okay to not put charges while balancing, because sometimes students get confused, although you should, but in the beginning when you're just starting, it's okay to not put charges when balancing. Okay. Okay, now here you have 1 copper and you have 2 aluminums and you have 3 sulfates, SO4. Okay, so ideally, like I said, there should be a charge, but you're still learning. So right now it's okay. We should just look at, there are 3 sulfates on one side, 1 sulfate on the other. Copper is 1 and aluminum is 2. So there are 2 aluminums and 3 sulfates. So let's see, can we make this 3 sulfate? So this means 3 times 1 copper and 3 times 1 sulfate. And that gives you 3 copper and 3 sulfate. Okay. So sulfate got balanced. Now there are 2 aluminum. So put 2 here. This 2 applies to 2 aluminum. So 2 aluminums and then put 3 here for 3 copper. Okay. So now let's look at this. We have 2 aluminums and 2 aluminums. We have 3 coppers and 3 coppers. We have 3 sulfates and 3 sulfates. So it's balanced. Ideally, you should put the charge, but for new beginners, it's okay. Then that is for the beginners. Only. Okay, now let's look at the other one. Lead nitrate and sodium chloride giving you lead chloride and sodium nitrate. Now here, what does it mean? It means that there is 1 lead and there are 2 nitrates, NO3. So that 2 outside the subscript applies to the nitrate. So 2 nitrates, there is 1 sodium, Na, and there is 1 chlorine. There is 1 lead. There are 2 Cls, there is 1 sodium, and there is 1 nitrate. So it's very important you recognize the polyatomic ions. Okay, so what is not balanced? Lead is balanced, sodium is balanced, chlorine and nitrate is not balanced. So there are 2 chlorines on one side. So if you put, and the nitrates are 2. So let's put 2 here. So that changes, and nitrates are 2. Let's do this here. Okay, so this 2 applies to sodium and this 2 applies to chlorine. So that means we have 2 sodiums now and we have 2 chlorines. So 2 sodiums and 2 Cls. All right. Then, so 2 chlorines are balanced, 2 sodiums. So this 2 applies to sodium and this 2 applies to the nitrate. So again, here you have 2 sodium and 2 nitrate. Okay, now 2 nitrates. So let's see what is balanced now. We have 2 sodiums, 2 nitrates and 2 nitrates, 2 sodiums and 2 sodiums, 2 chlorides and 2 chlorides, all balanced. Okay, so that's the way you do it. Just keep this in mind that the subscripts outside the brackets, they apply to that particular entity that is within the bracket, okay? Or at the base, like for example, in chlorine and the nitrate, that's what I'm talking about. All right, now let's look at the, we need to write the formulas. We need to write down the, like the solid, liquid, gas, or aqueous, and then we need to balance. So here you have, put here you have lithium metal. So lithium metal means lithium, and it's a metal solid, okay? Reacts with liquid water, so reacts with H2O. Water is H2O and it's in a liquid state, liquid, to form hydrogen gas. So this gives you hydrogen gas, H2 as a gas. And aqueous lithium hydroxide, is LiOH and aqueous. Now, lithium hydroxide, the formula of the lithium hydroxide is LiOH. Hydroxide is OH and lithium is in group 1A. So plus one charge. So only one OH ion. Very important to write the correct formula. Okay. Now, we write this down and then we are going to balance it. So let's look at what is there. So we have one lithium. We have two hydrogens. We have one oxygen. We have two hydrogens, we have one lithium, we have one oxygen and one hydrogen. So all this is, wait 1 second. There are three hydrogens actually. So three hydrogens, so two hydrogens on one, and there is a total of three hydrogens on the other side. So what will you do? You have to balance it and, H2O, so lithium, OH, so oxygen, so hydrogens are not balanced. So if we make it, a minute. Okay, so here the tricky part is where to start. So, you know, if you start with lithium hydroxide, which means that we see that the hydrogens actually are two on one side, but there are three hydrogens on the other side. So we need to fix the hydrogens, okay? So lithium, so look up the oxygen later. So first thing, so bring two here. So this two applies to lithium, oxygen, and hydrogen. So this makes it two lithiums, two oxygens, two hydrogens, and you have two lithiums, two oxygens, and two hydrogens. Plus this hydrogen also. So there is two hydrogens plus two hydrogens, a total of four hydrogens on one side. And now we can make it four hydrogens on the other side by putting two here. So this applies to hydrogen, this applies to oxygen. So now you have 2 times 2 hydrogens, 4 hydrogens, and you have 2 oxygens. Okay, so the only thing that got messed up is the lithium. So you can easily put 2 here. So this 2 applies to lithium and you have 2 lithiums. Okay, so you see now that you have 2 lithiums on one side, 2 lithiums on the other side. You have 2 oxygens on one side, 2 oxygens on the other, and you have a total of 4 hydrogens on one side and a 4 on the other. So you have to combine the hydrogens or you know, whatever entities are. Okay, so this is how you work on this one. Now let's look at the next one. Next is the, let's put it with a different color. Next is hydrogen sulfide gas. Hydrogen sulfide gas is H2S and gas is G. Okay, and solid iron 3 chloride plus iron 3 chloride is FeCl3. And solid, it's a solid, S, okay? React to form solid iron 3 sulfide. So react to form solid iron 3 sulfide, iron 3, Fe2S3 sulfide, and this is solid, okay? And that, and hydrogen chloride as a gas, HCl is as a gas, okay? So this is your reaction with the, you know, phases also. Okay, next is, let's look at the number of atoms in balancing. So there are 2 hydrogens, there is 1 sulfur here, there is 1 iron, and there are 3 chlorines here. Okay, there are 2 irons here, and there are 3 sulfurs here. There is 1 HCl, 1 hydrogen here, 1 Cl here. Okay, now, Okay, so irons are 2, chlorines are 3, and 1, and sulfur is 1. And so pretty much nothing is balanced. So let's look at the where to start. So you can, because hydrogen is 2 on 1, so we can work around with that. If they're just 1 and 1, it's easy to work. But let's look at that. So one is iron is 2 on one side, so, and iron is none on the other side. So let's make it, so we have to bring 2 here, we have no choice. So this makes iron 2 irons on one side, and now there are 6 chlorines on one side. All right, so we will have to make the other 6 chlorine also, but hold on to that. So iron is fixed. Let's look at sulfur. Sulfur is 3 on one side, but sulfur is 1 on the other side. So if you make it 3, so that makes 2 times 3 is equal to 6 hydrogens, and 1 times 3 is equal to 3 sulfurs. So sulfurs are balanced. Now hydrogens, 6 hydrogens, 6 means 6 applies to hydrogen and chlorine. So 1 times 6 of hydrogen and chlorine each gives you 6 hydrogen and 6 chlorines. Okay, so let's see now what is balanced. So we have 3 sulfurs here and we have 3 sulfurs here. We have 6 hydrogens here, 6 hydrogens here. We have 2 fluorines here and 2, sorry, this is not fluorines, 2 Fe. We have 2 Fe. 2 Fe, sorry. Fe. Okay, so 2 Fe one side and 2 Fe on the other side. Okay, and then you have 6 chlorines on one side and 6 on the other, and that is balanced. Okay, now we are going to look at the question number 13. Question number 13 is, let's see. Okay, here question number 13 is about classify. Let me make this bigger. Classify each of the following reactions as decomposition, combination, single replacement, double displacement, or combustion. Okay, so here the classification. So I'm not going to write this, but I will just explain. First of all, this is aluminum oxide is getting decomposed. So when it's like a bigger one substance is there, you're just basically heating it. The delta sign, you see this sign, this delta sign is the sign of heat when something is being heated. So we see when aluminum oxide is a solid, is being heated. That's what it means, is being heated, and that is producing the components of which aluminum oxide is made up of, aluminum and oxygen. So this type of reaction is a decomposition reaction, breaking up into smaller parts. Okay, next is bromine reacting with BaI2. So what is happening? BaI2 and bromine, BaI2 and bromine reacting. So this is basically breaking up the BaI2, displacing that iodine, and bromine forms a bond with barium. So here in this case, this looks like a single displacement reaction. Okay, it is not a combination because it's obviously breaking up the bond of one of the entities. It's not decomposing, it's not double displacement, it's not combustion. So it is a single displacement reaction where one entity breaks the bonds of the other entity and relieves one of its components. Okay, next is anytime you have something that is carbon hydrogen carbon hydrogen like that, oxygens or whatever, so that is the hydrocarbons. When these react with oxygen, right, whenever they react with oxygen, they always give carbon dioxide, water, and a massive amounts of heat. Although we don't write heat, but these type of reactions are combination reactions. Combustion reaction. Combustion always occurs whenever oxygen is present. And it's always, for us, it relates to the hydrocarbons, carbon, hydrogen, okay? And then it breaks up into carbon dioxide and water. Next is BaCl2 reacting with potassium carbonate. BaCl2 reacting with potassium carbonate. Now here, BaCl2 is made up of barium and chloride ions, so 2 things. And here you have potassium carbonate made up of potassium and carbonate ions. So when barium and potassium carbonate, both of them are soluble in water. They ionize, they switch places. And as a result, barium forms barium. Barium combines with the carbonate, gives barium carbonate, and potassium combines with the chloride, gives you potassium chloride. So here in this case, this is a double displacement reaction because everything breaks up into ions and then it switch places and you have a new substance form. Okay, so the outer, inner. Outer means outer. The metal of one reacts with the non-metals or the polyatomic ions of the other. Okay, and then the inner is the metal of one and the non-metal or the polyatomic of the ions of the other. They make new bonds. Okay, now the last is lead combining with oxygen. So this is a very simple combination reaction because it's just producing this entity. Okay, lead oxide. So this was about, classifying, and you should practice the others also. So just so you understand and know them. Okay. So for now, I'm going to just stop this here. And in the next video, we are going to look at the redox reactions, the oxidation reduction reactions. And we are going to do in the next video, question number 19 and 20. All right. Okay. All right. So that's all for now. Thank you. Thank you for watching. Bye-bye.